Okay, so let me just start solving these problems for you, and then we continue the lesson. If you remember, we had some rules. Of course, I know that in this book they are spread around the exercises, but I actually wrote them as a theorem. So if you want to use them, you are just free to use them, okay? And that's my goal here. So here, I think this problem is simpler. I should have written this one first and then come back to this one, because I think this is more or less trivial. Yes, do you remember? One property of union of two sets was that if I know that two sets are comparable, then if I union them, what will happen? Comparable means that one of them is a subset of the other one. If I have such a pair of sets, if I union them, what will happen? It becomes the bigger one. Yes? So that's the idea. So if I want to talk a little bit here, A union C, I need to see that if they are comparable or not. But we have also another property. Do you remember? This tells you that A is a subset of B and simultaneously B itself is a subset of C. If you remember, I was talking about transitivity property. Forget about the name. It tells you that if A is subset B, B is a subset of C, there is an immediate consequence of this comparison. And that is A is a subset of C. And then this tells me I can write something for A union C. Because now I know that A and C are comparable. So if I union them, the answer becomes the bigger one, which is C. And now what about B and D? The same story. Here we have B given to us to be a subset of C. We also have been given this condition that C is a subset of D. If you remember, this was a transitivity property once more. B is a subset of D. And when B is a subset of D, what can I conclude about B union D? It becomes the bigger one D. So therefore, the question mark that I have, the question mark is equal to. Instead of the first pair of brackets, I can just simply write C. And in the second one, I can write, of course, after that I have the union, and then after that I have D. But can I still simplify it more?
Yes.
Yes, because C and D are also comparable, and then it becomes the bigger one. So the answer to this is actually D. And this is the simplified version of that. Of course, you can immediately answer that because you know that because of associativity, because I don't care about where do I put pair of brackets, all of them are unions, I can take them away, and then I see a bunch of unions, and all of them are comparable. So D is the bigger one, so I can immediately answer that the answer should be D. But this is a systematic way to answer that one. Okay, so I don't know, I should have written this one first because this is a little bit simpler than the previous one. Here, I have been given two sets A and B. I do not know anything about the elements inside A and B. What I know is that A is a subset not of B, but the complement of B. Yes? So for example, if you want to draw a Venn diagram to imagine that, how do you draw the Venn diagram? So if this is B, where is B complement? Everything outside B. And A is a subset of B complement. So what it means? It means that if I want to draw something for A, I have to respect this rule that I'm not allowed to come inside B. Yes? So when you say that A is a subset of B complement, this would be the situation, yes? Of course, this is just a visualization. You need to use the theorems and problems to be able to answer that question. For example, the last pair, this expression, I can immediately answer using that. Yes? Because if you tell me that A is a subset of the B complement, it means that B complement and A are comparable. And now in the last pair of brackets, you are asking me to union them. Yes? So what happens? If I union them, it becomes the bigger one. But which one is the bigger one in this case? B complement. No, B complement is the bigger one. So it becomes B complement. Okay? Now, my question for you is about this. So, A complement union B. What can I write for this one? So, what I calculated so far, I was able to calculate this inside this pair of brackets. Let us keep it for the time being and jump here. So, what can I write for A complement union B and why? Yes?
A complement.
Why?
Because B is in A complement.
How do you understand? So by this visualization, yes, I just want you to see the formulas. Yes, you are right. It's completely clear. If you imagine this is why I actually drew this picture. So if you compare, because by this condition, do you agree that I have to draw something like this? Yes, because B is somewhere, B complement is everything inside the rectangle outside B, and A lies in B complement. So A should be somewhere here. Well, then it is clear that A complement, so B is a subset of A complement, yes? Because A complement would be outside A, it automatically contains whole B. So B is also a subset of A complement, yes? But that was a reason that we had it before. Do you remember? I told you before that if a set is a subset of the other set, and I insist to take the complement from both sides, what should I do? You answered actually. Yes? You switch this one. So it becomes what? It becomes B complement is a subset of A complement. So that was a very important rule. If A is a subset of B and I want to take complement from both sides of this relation, I can do it, but I have to remember I have to swap these two. Yes? So now you are telling me that A is a subset of B complement. So according to that rule, I want to take complements from both sides, but then I have to do it in this way. I just want you to understand this arrow is that rule. Is that understandable for everyone? So I am taking complement from both sides. So I have to put complement, I have to put A complement, but I also have to remember to swap these two. But then I had another theorem. What was B complement, B complement? It's just B. So instead of this one, and what you predicted using this graph or this diagram was actually correct. And now that I know that B is a subset of A complement, it means that if I union them, what would be the union? These two sets are comparable. Which one is bigger? A complement is bigger. So the answer would be A complement. Yes? And now I go back to question mark. I think everything now is ready. For A complement, I cannot write anything. So I just copy and paste that part. And then I see a union. So I copy and paste that union. But instead of this expression, I just found it is A complement. But I have another complement on top of that. So this becomes A complement. And then I have union, and then this one is B complement. Understandable?
Yes.
So I have been using this idea that if two sets are comparable, the union is the bigger one, and of course I also use that property. Okay, and then I can simplify this. A complement, I cannot write anything except A complement itself. Union, but I can write something for this is A and then B. Okay, now this is two unions, and I think you remember that the union operation is also associative. So it doesn't matter. If I do these two first, find the answer and union it with the third one or the other way around. Yes? So what I do, which one do you prefer? The first two is a very good one. Yes? Why is that? Because we also know a formula for this. A complement union A is the universal set, and the universal set being unioned by another set. The answer is the universal set. Yes? So that's just the universals. So that is, yes.
On the test, we have to do every step that we just showed.
Yes.
To
Yes.
get full marks.
Yes. But I don't know. I haven't checked the exercises in the book. If they contain such a problem, I will give you. Otherwise, I wouldn't know. But I think this is something not very hard. You can just learn that, even if it is not in the book. Okay. Any questions? So, okay, we started talking about the notion of a set. We learned a little bit about them, and then we defined equality between them, and then we defined subset relation between them. And then I told you that this becomes more or less useless unless we can somehow combine different sets together. So we want to talk about operations between sets or algebra of sets. The first operation we defined between two sets was the union operation. And now there are two more, and both of them are in the book. One of them is called intersection, and the other one is subtraction. So these are the only operations that we want to talk about, okay? I think we can cover both of them here today. But then, might be the combination of these properties will be left for the next session, okay? Of course, the idea of intersection is probably clear. That is more or less the English word, yes. So let me write here definition. The intersection, this is the word we are defining. The intersection of sets A and B is denoted by this symbol. We write A. The sign for intersection is the opposites actually for union. So be careful, don't make mistakes. And I think it's a good idea. Union starts with U, and it is exactly similar to that symbol. So the other one is intersection. It's denoted by this and is defined as follows. Okay, so A intersection B. Before this, let me just remind you of what was A union B. Do you remember? It was the set of all elements. Of course, they should come from the universal set, but such that what happens? Do you remember the definition of the union?
X belongs to A or X belongs
Or, yes. X belongs to A, and then I use this symbol for or, X belongs to B. Okay? But now, I think you can also guess what would be the definition of the intersection because of the English word intersection, yes? So, what is... Yes?
So X belongs to the universal set and X belongs to A and
exactly. So this or becomes and, yes? So then, I would say X belongs to the set of the universal set such that I am interested in all X's from the universal set with two extra properties. One property is that X belongs to the first set and X belongs to the second set. So this is and. Okay, so if I want to give you a feeling of by the Venn diagram, so for example, let me just draw this rectangle to be the universal set, and let me take this one to be the set of A, and this one to be the set of B. So then this part which lies in both of this part is not a point in the intersection because it is neither in A nor in B. This one is not because this is in B but not in A. This point is not because it is in A not in B. So the points that are both in A and B simultaneously are these points. Yes? So this is, for example, in this picture, this is A intersection B. For example, what happens if I have this situation? If I have A here and B here, where is the intersection? So what should I write? So if I ask you what is A intersection B, equals to the empty set. Okay, it's very important. Don't say 0 or whatever. You have to write the empty set. So there is a terminology. It's good to know. When two sets, the intersection of two sets is the empty, we say that they are exclusive. Okay, so they don't have anything in common. Okay, and then, for example, what happens if I have this situation? For example, assume that A, so this is B, A is inside A. Sorry, A is inside B. So A is a subset of B. So do you think where would be A intersection B? Just A itself, yes? So this A itself, in this case, A intersection B is also equal to A. Then you understand something in this case, yes? In the union case, if two sets are comparable, the union becomes the bigger set. But in this scenario, if two sets are comparable, the intersection becomes the smaller one. That would be a property that I will mention later. What happens if I have the other way around? If this is A, oh sorry, this is B, this is A. That's the same thing more or less, yes? This time it becomes B. So here, A intersection B is nothing except B itself. Okay, so the notion of intersection is also simple. So you are looking for those elements that simultaneously are both in the first set and in the second set. You write them in curly brackets, that would be your intersection. Yes? So for example, I don't know, these are very simple examples. If I have A equals to 1, 5, minus 3, and then I have B equals to, I don't know, so 5, 3, 2, and 1. Then if I ask you what is A intersection B, it is what? 1 and 5. And it doesn't matter how you order them, 5 or 1 or 1 and 5. So that is A intersection. Yes? So if I give you A to be this set, the empty set and this one, and then I give you B to be okay. So is there any intersection between these two sets? What is that? Yes, I have to write intersection B. So you see that this is the one which is exactly in common, yes? Nothing else. So how should I write it? Is this correct way of writing? No, I have to add another curly brackets, thank you, around that. So that would be A intersection. Yes? So intersection doesn't have actually any problem. Then I want you to rediscover all the... Daniel, do you want to say something or we continue?
No. Yeah.
Continue. Okay. So now I want you to, I don't know if you have your notebooks with you, there was a theorem that I expressed for the union of two sets or more sets. I want to put that in front of you and then write similar formulas for intersection instead. So I don't know, do you know which theorem I'm referring to? So let me just write this theorem. So I would say that let A, B, C, and D be sets. Yes, then So do you remember? I don't know. I don't remember myself. Which one I wrote first? Can you read it for me? A union A is equal to.
the empty set.
Okay, A union the empty set is equal to the A itself. I want you to write the analog of that for intersection. For example, the first one, instead of writing the union, you write the intersection and then the empty set. In that case, the answer was A. In this case, apparently the answer becomes the empty set. So what I want you to do, I just give you, I don't know, 2 or 3 minutes by pausing this, recording the video. So I want you to complete that. Every item there has an analog here as well. I want you to write that analog yourself. Thank you. By the way, why A intersection empty set is the empty set? Of course, it is clear, but if you want to convince yourself, you would say that let X be in A intersection the empty set. So what can I conclude? If there is an element here, this element should be both in A and in the empty set. But this cannot happen, yes? This is why you cannot find any elements in the empty set. By the way, let me also write this remark for you somewhere. It might be better if I write it here. Of course, you know that, but let me just emphasize as before. So, if someone tells you that X belongs to A intersection B, what can you conclude from this? That X belongs to A and X belongs to B. Of course, the other way around is also true. But can you translate this one for me? If X does not belong to A intersection B, how do you translate it in terms of belonging to A, belonging to B? Yes?
X does not belong to neither one of them. So
No, be careful.
Oh.
You have to be careful. That's more or less all of you did the same mistake for the other case.
it can belong to one of them.
Pardon?
Måste prata bara
X does not belong to what?
It can belong to one of them, but it doesn't belong to both of them simultaneously.
Yes, so okay, that's a long story. Make it short. Yes, make it, you are right, but make it short.
X does not belong to A, or X does not belong
Yeah,
to
that's enough. Yes. So X does not belong to A, or X does not belong to B. So that is good to write somewhere. We had something similar, if you remember, but I remember I forgot to put this double arrows. You can go back and make it double arrow, because in that case that was also correct. Okay, so this is number 1. Now, I don't remember the order, so you can help me. What was the other one?
A intersection universal set.
Okay, so A intersection the universal set. What would be the answer? What's your guess here? It's the A itself. Yes? What was the analog here? A union the universal set was the universal set. But in the intersection case, it becomes the set itself. Yes? Okay, number 3. What was number 3?
This was a little hard to. It was about commutativity.
Yes?
So.
Didn't I write something? Did I write something for you? If I haven't, that was my mistake. Did I write something like this?
No, you wrote A union B is equal to.
Oh, so that was my mistake. That was also good to write. Yeah, please write it there. A union, any set union itself is equal to itself. This is good to write it down. Okay, of course it is trivial, but it is good to write it down. Do we have the same scenario here in intersection? A intersection A is also A. So please go back and, I don't know, add it somewhere. So let me write here A intersection A is equal to A. So it is very nice. It doesn't matter how many times you repeated it in intersection, it's exactly the same thing. Okay, so that was my mistake. Okay, number 4 is commutativity. So do you think the order of intersection matters here? No, so that's the same thing. So A intersection B is equal to B intersection A. It's called commutativity. So number 5 is associativity. So it means that if I have three sets to intersect, it doesn't matter if I do this pair first or if I do this pair first. The answers are the same. Yes? So number 6, what was number 6 there?
A intersection, A complement.
Okay. So A intersection, A complement. In the case of union, A complement was the empty set. Sorry, was the universal set. In this case is the empty set. Anyone else here? So number 7, I don't know, the numbers probably doesn't match with those numbers because we add something here. 1, 2, 3, 4. Do you remember I was always going from 2 to 3 and then 3? There was something in my brain. I didn't realize that I had missed this one. Okay. Anyway, so number 7. How do you read number 7 in this case? Can you read it in the case of union for me first? I don't know if the number 7, I mean the next one.
A is a subset of B and C is a subset of D, then A.
No, but before that, so this, yes, you are right, that is number 7 there. But read number 6 there. There is an analog for number 6
no,
there.
that was number 6.
Oh, that's 6, okay. So what is that? If A is a subset of B and
C is a subset of D.
Okay, so do you remember we were able to union these side by side?
Yes.
Can we also intersect them side by side? Yes or no? Can I write A intersection C is a subset of B intersection D? Do you think that's correct? A intersection C, B intersection D. This relation still holds. Yeah, it seems to be right. But if you want to prove it, you have to go through. I will try to prove it as an exercise. Let us keep it and go to the next one. So what is number 8? Probably that is if A is a subset of B. Yes.
Yes.
Okay. In the case of union, the union becomes the bigger one if they are comparable. The intersection becomes the smaller one. And I wrote something here as an exercise, and I would bet that you didn't do it. Did you? Did you do the other way around as an exercise? So this one is more or less trivial. The other one is also very interesting to know. If the intersection of two sets is equal to one of them, that one is the smaller one. Okay, so this one is more or less easily understandable. This is also easy, but you need to work a little bit out. So these are the properties. You see, they are actually analogs of the union of the sets. And if you, okay, so let us immediately use them for this exercise, for this example and this example. So let me just clean this first part we don't need, and let us keep the theorem so that if we want, we can refer to the number of the items that we are using. Okay, so what do you think here? So number 1. So the question mark is equal to. What should I write? I have an intersection in the pair of brackets. So can you tell me what is the answer to this part? By the way, do not invent new rules, okay? Do not apply this C on this C and say it becomes A. You're not allowed to do that because this pair of brackets gives the priority to this operation, not the complement operation. So you have to do this one first, and then after it is done, then you are allowed to use this complement operation, yes? So what is A complement intersection with U?
Is it A complement?
Yes, because any set intersection with the universal set is the set itself. Yes? So this one is a set which I am intersecting it with the universal set. So it becomes the set itself. So it becomes A complement. And on top of that, there is another complement. So it is just simply A. So number 2. If you want to, I can write the number here so that at home, if you forget, you remember that for this equality to hold, I use this number. Okay, and number 2. So what should I do here? So the question mark is equal to. I have two pairs of brackets to take care. This one is actually exactly number 2, so instead of this one I can just write A. And then I have intersection, and then I have B complement, I have intersection, okay? This is a little bit technical. You might think it is trivial, but I want to follow all these rules very rigorously, okay? So here, I have a pair of brackets here. I use commutativity to interchange these two. Yes?
Yes.
So commutativity is being used here, number 4. And I use associativity to take these pair of brackets and put them around these two. Yes? So then it becomes A intersection A complement and then intersection B complement. Which property I have used here? Property number 5. Yes?
Yes, yes.
And now A intersection A complement is property number 6, which is empty set. Yes? And now, what is the answer? What is the answer? The empty set, which property? Number 1. Because it tells you that, just read it like this. Any set that you have intersection with the empty set is the empty set. We don't care about the name of that set. Here I have a set, I am intersecting it with the empty set. So the answer is the empty set. And if you want to write the rule is the rule number 1. So here what I have used in this question mark, I used rule number 2. So you see number 2, 4, 5, 6, and 1. All of them you have to use them in order to get that one. Yes? So be careful. If one of these properties are not there, this will not work. Okay, so that is number 2. So let us go to number 3. So if you don't mind, let me just clean number 1. So here, number 3, the question mark is equal. So I think this is very, very simple. What is I want to hear from you. What should I do first?
So, it's just. It's like.
Yeah, what's the answer? So you can immediately say something about this. You really don't need to do it step by step. Pardon?
Empty set?
Yes. Because what we learn, I want you to understand how to read these formulas, yes? So this tells you that if you want to read this, don't read it A intersection A complement is the empty set. This has a deeper meaning, yes?
Yes, yes.
Any set intersecting with its complement is the empty set. This is the way that you have to read it. It's just like poetry, yes? You read something, but there's a deeper meaning to that. So this is a set. Who cares the name? And then this is the same set complement. I am intersecting them. So the answer is the empty set. Yes? So this is the empty set. So let me just write it here. So which property I am using? Property number 6. I copy and paste the first part. And then I put the empty set instead of this package. But don't forget about this complement here. Okay, but then what is empty complement?
Universal.
The universal set. So this becomes A intersection the universal set. This is not one of the properties listed here. We had it before. But A intersection U is this number 2, which is A. Okay, so that is also possible. Now here, this is the first, no, this is not the first time. Here you see I have a combination of the union and intersection. We will talk about these combinations more extensively later. But here I also have a combination here. But here, which one has the priority, intersection or the union?
Union.
The union, because it is in the pair of brackets, yes? So, but this is one property of the union. You need to remember of that property. You need to remind yourself of that property. So, number 4. The question mark is equal to. So you see here, I put this pair of brackets, I put the complement on top, I don't have to do anything with this part yet. I just copy and paste these parts. But for this, I can write something from my previous knowledge about the unions. It's the universal set. And then there is a complement left here. If some of you are thinking that complement can immediately act on this complement to get rid of, this is not correct. Because you have to do this first because of this pair of brackets, and then do the complement, then do the intersection, and then do this complement. So you cannot apply this complement immediately on that. So what is the answer to this? As you said, it is the universal set, but there is a small complement up there. So I have to calculate this. So then, what can I do? Instead of a complement, I cannot do anything. So I just copy and paste. But this I know. This is the empty set, and I have a complement on top. Okay, so what happens for this? Today we studied that.
The empty set.
The empty set, and then I have a small complement there, so this becomes the universal set. Yes? Understandable? Okay, so this 4 part is finished. Let us simplify this one as well. No, I think now you have it in your memory. So I was supposed to prove this one for you. Let me just do it again after this is finished. So let me clean everything else. Okay, so the next number, A, B, and C are sets. We have these 2 pieces of information. We know that A is a subset of B complement. We also know that C is a subset of B. We are supposed to simplify this expression. So I think we can write it immediately in front of it. So let us start. Can I write something for this? Apparently not, yes, because we do not have any information regarding, might be we can, by the way. Because here, if I want to write something for this, if I do not have these pieces of information, no, I cannot carry on. Because I don't know anything about C in that case, I don't know anything about A complement. But might be I can find a connection between A complement and C. Do you think that there is a connection? Of course, in this way of, I have connected A to B somehow, and I have connected C to B, but I want to somehow connect, if possible, A and C somehow together. So what should I do? Is this possible, or should we go carry on?
B is a subset of A complement.
B is a subset of A complement.
And C
yes?
is a subset of B. So C is also a subset of A complement. Which means that
so let me understand. Yes. C is a, yes. Thank you. So here, so you start from this assumption. I want to take complements from both sides, but there is a rule for that. You can do that, but you have to swap these 2. Yes. And then what happens? This is B, A complement. Okay, now the interesting thing happens here. C is given to be a subset of B from the beginning. I realize now that B itself is a subset of A complement. Yes? So then what can happen here? C is a subset of A complement. And there I am intersecting exactly these 2 sets, so I'm lucky. So what is this? C, because if they are comparable, the union becomes the bigger one, the intersection becomes the smaller one. So the answer to this is C. Thank you. That was probably the hard part here. So instead of this expression, I can write capital C, but I have complement, which becomes C itself. Yes? So this one becomes C. Can you tell me what happens here? We have it on the board. We don't need to do it again. Is B and A complement comparable?
Yes.
Yes, we just found it. B is the smaller one. And then I am intersecting them. So the answer becomes what? This union is this union. This becomes B. But we don't need anything for answering this. A intersection A complement is the empty set. So then it becomes the empty set. The empty set, what happens here? By the way, it doesn't matter how you interpret that. For example, I can put them in this pair of brackets. But can you tell me what is the answer to this? What is the answer? The answer is B, because this is union. Thank you. And then I have intersection union by empty set. This is B. So that was a good question, actually. Yes, that's correct. Any questions so far? So let me put this as an exercise, okay? I want you to write down the proof. Let's do these exercises. I don't know, should I start also the next part or not? Are you tired? No? Yes? No? Yes? Are you?
No.
Pardon? Well, for the next part, I know, but because the problem is that in the book, this is just half a page. They don't talk that much about this, so immediately they go teach everything. Okay, but then in the exercises, you face a little bit of problems, yes? And if I don't finish the next part, then I cannot assign you some exercises. Then there would be a mixture. Okay, might be this is the last session for Math 5 this week. Yes. So if you don't mind, let me also at least introduce you the final operation between two sets. We can define them. Okay, before that, let me give you an example. This example is also simple. Let X and A be sets such that X is both a subset of A and a subset of the A complement. Prove that X is equal to, I don't write the equality, I want you to guess. This is easy because I want you to develop having good feelings with sets, you know. You start loving them. So, yes, if you love them, then you can read them. So, if X is a subset of A, simultaneously it is a subset of the complement. What can you say about the set X? It's the empty set. So you have developed your feeling already, yes, with sets. So X should be the empty set. Yes? But of course that's just a feeling. But this is not educated guess probably. We want to prove it mathematically, yes.
I mean, okay, we can prove it mathematically, but can't we just use the argument that every set contains the empty set?
No, the other way around. First of all, I don't like the word contain because I think we use contain for membership.
Yes.
So, for example, if A belongs to A, I would say the set A contains element A. Yes. So, but in the same sense, we have only one word in mathematics which is not ambiguous, and that is the subset relation. So you can say that. Sometimes mathematicians also use that, but the empty set is the subset of every set. Okay? But what I don't understand why you have this feeling from this one you can conclude that X is equal to an empty set.
Because it's no other set has the quality to belong to the set and its complement.
Exactly. So you are forcing me to accept that. Exactly, that's the argument. Why? Yes.
Because they don't intersect.
Yes. So yes, that's exactly the idea. They don't intersect. I want to use this property here. Okay. Might be you can also cook up another statement, but I can use that. I would say that X, you are telling me, is a subset of A. You are also telling me that X is a subset of A complement. According to that rule that is left as an exercise, I can start intersecting both sides. Yes? So I can write X intersection X is a subset of what? A intersection A complement. Yes? Which rule I am using, I don't remember. Was it number 8? Or, no, it was 7. I don't remember what the name was. So this number. Is that understandable that I am using that rule on the board? But I have another rule. What is X intersection X? It's X. We have another rule. What is this one?
The empty set.
The empty set. So far I wasn't able to show that X is equal to the empty set. I showed that X is a subset of the empty set. But now what you said is relevant. We proved that this is the case. In this case, we already know that the empty set is simultaneously a subset of any other set, including X itself. And then we know that if A is a subset of B and B is a subset of A, they have to be equal. So then it means that this means that the X is the empty set. So the feeling actually was correct, but that is probably a good argument about that. Okay. Or if you don't like this method, you can use the proof by contradiction. I really emphasize on these things because these are very important. I want to show that X is the empty set. Let us assume that no, this is not the case. If this is not the case, what does it mean? It means that there exists an element in X. I am claiming that X is empty. If you do not agree with me, then you have to agree that X has at least one element. Let me call that element X. Little x. Yes? But you are telling me that X, I know that X belongs to X, and you are telling me that X is a subset of A. What is the conclusion? So this little x should also be in A.
Yes.
Yes? Now I also know that X belongs to X. You are also telling me that X is a subset of A complement. So what can I conclude? That X belongs to A complement. Now X belongs to A and to its complement. So X has to belong to the intersection. Yes? Because if X belongs to A and X belongs to B, this means X belongs to the intersection.
Yes.
X belongs to one set, whatever the name is. X belongs to another set, whatever the name is. So X should be in the intersection. But you know this. What is that? The empty set. So X belongs to the empty set. But this is contradiction. So if you do not agree with my claim, then you have to admit that there is something in the empty set. Of course, if you want, you can accept, but this is contradiction. Yes? So that is also completely correct, but I think this was easier because this is somehow using algebra. But this you need to start writing all over everything all over. Okay. Okay. Before let us have some fun. You know. Let me ask your opinion about this. Do you remember what I talked about a power set?
Yes.
I told you this is optional, but let me remind you, what was the power set? So at least if you are tired, if you don't understand this part, you don't lose anything. Okay, so let us just do some exercises. So if I ask you, if I give you this set A and B, do you remember what is the power set?
All the subsets.
A set containing all the subsets. So writing all the subsets is in the book, but the notion of the power set is not. So the only thing that you need to do is to put a curly brackets around them. Yes, that's the power set. So if I ask you what is the power set of A, so you have the smallest subset of every set is the empty set, and then I can write the set containing of only one element A, another one containing of this one, and another one is A and B, and then I put them in another curly bracket, that's the power set. Is that right? Now,
Do you
yes?
not include the set itself also?
This is the set itself. Yeah,
it is.
either you write it in this way or the set itself. I prefer to write
writing
it.
A.
Yeah.
But, yeah.
Now my question is that what is the power set of the empty set? Write this one and check it against my answer. What is the power set of the power set of the empty set? And what is the power set of the power set of the power set of the empty set? Okay? So let us just do these exercises. So let me do this one and then finish. So what is the answer in front of this? If you want to say it, just read everything, curly brackets and whatever. What should I write in front of this? Curly bracket, and then this sign and so what happened? Your voice perished actually. So what should I do? Yes, I have to close it. That's the answer to this. Yes or no?
Yes.
Why is that? By the way, the empty set, how many subsets are there for the empty set? One, and that is the empty set itself.
Yes.
So then I have this in my list, I put curly brackets around that.
Yes.
So what would be the answer to this if you want to read everything? Yes?
Curly brackets, the empty set, and the set of the empty set. And then close.
Yes. So that's the correct answer. Yes? By the way, this is a very nice thing to see. The empty set, in mathematics, this is called zero. So you are constructing numbers based on set theory. This is what we say 1. Okay, and this is what we say 2. And the next one is what we say 3. And then we define operations between 2 and 3, and then we realize if we add them, it becomes 5. Okay? So everything is coming from set theory, actually. So what is this one? How many elements are there before any calculations? 4. Why? Because the previous one has 2 elements. So I open a curly bracket. Let me close this, not to get confused. The empty set I should start with. And then what should I write? The curly bracket, empty set because of this. And the curly bracket, this because of that. And then what is left? So that is the P. So that is called 3. But that's very strange. No, this is not 3, by the way. I made a mistake, sorry. This is 2, but this is not 3 because there are 4 elements there. Yes. So I forgot how to define that problem. Okay, but anyway, this is around these things. So numbers are also sets. When you want to start set theory, you don't have anything except sets. Whatever you want to talk about, you have to construct it first. Okay, thank you very much. We continue the lesson next week. So remember, in 4 weeks, more or less around that time, we will have an exam for chapter 1. Yes? Right. In 4 weeks. Yes? 3 more weeks we have lessons, 1 week for practice and then exercise.